This module is the threat prevention configuring the exploit prevention protection. The threat prevention module in our McAfee endpoint security provides a content-based exploit prevention capability. This capability is going to replace the McAfee Virus Scan Enterprise buffer overflow protection and provides a broader range against the different vulnerabilities and exploits. What we will learn in this module is we'll be able to describe the key features of the ENS exploit prevention and how to configure the exploit prevention policies to meet your customer needs and requirements. For the centralized management platform, exploit prevention is also configured from EPO in your policy catalog. We can also access the standalone configuration where I can configure the settings and access control settings of the endpoint client within its interface. The key features of this exploit prevention is the exploit prevention itself, the generic privilege escalation, the Windows data execution prevention, our exclusions, our signatures, and our application protection rules. This section actually has to do with where it also prevents buffer overflow exploits from executing arbitrary code on your computer. The endpoint security threat prevention comes with two policies by default: the McAfee default, which is a read-only, and the My Default, which you can edit and is a duplicated policy of the McAfee default. The settings for exploit prevention, we have first off that you do have it enabled, so please do not disable this because this is what is the main feature that makes sure that this is running. Okay? If you disable this, then your system will be unprotected from all the malware attacks that can happen on your system. The generic privilege escalation is disabled by default. You can enable this if you want to use the GPE signatures that exist in the exploit prevention content to give you more coverage in your kernel and user mode. You have the Windows data execution prevention, which is a Microsoft Windows operating system security feature that is designed to prevent damage from viruses and other security threats by monitoring the programs to ensure that they use the system memory safely. It is optional for you to enable this. If you do enable it, you can enable it for 32-bit applications if it is not already enabled. Basically, all the caller validation and targeted API monitoring are still enforced. You can monitor for the DEP detections in our 32-bit applications. You can also monitor the DEP detections in 64-bit applications in our McAfee application protection list. You can also log all the DEP detections and send the event to EPO. But because it is enforced by the operating system, this protection will impact performance in your API coverage. When disabled, all DEP-enabled processes and the Windows DEP policy are not impacted. On the signatures section of the exploit prevention policy are all the different rules that will be able to compare behavior against known attacks. This feature is what the IPS rules feature was for host intrusion prevention. Basically, McAfee will give you new signatures that will be in any of the exploit prevention content updates. I can change the action settings for these signatures, but you cannot actually change these signatures. The signatures are designed to protect specific applications which are defined in the application protection rules list. When an attack is detected, the exploit prevention can stop the behavior that is initiated by that attack. When you have the content file updated, you'll see a new list of signatures updated if needed. When you get the new content file updated, you will automatically see what the action is set for the signature depending on the severity level. The severity level actually has no effect on whether or not the signature is blocked or logged. But the only thing that I can do is change the action for that specific signature in this exploit prevention settings. Any changes that you make will change the signature actions throughout your content updates. Now, if you want to protect specific files, shares, registry keys, registry values, processes, and services, you need to create custom access protection rules. This is what we used to do in the host intrusion prevention, is that you would create custom IPS rules in host intrusion prevention. You cannot create custom signatures in the signature section of this policy or product. If you want to create those same custom signatures, they actually are now called access protection rules. To understand how McAfee defines the severity levels of these signatures, the high severity is a clearly identifiable security threat, or it has malicious actions. The medium type of signatures are very behavioral in nature, and they prevent applications from operating outside their environment. We have shielding and enveloping, where you'll shield an application from another application stepping into its files and registry settings. And then enveloping is where I actually prevent an application from stepping outside of its files, folders, and registry settings. The low severity, once again, are behavioral in nature, and they shield the different applications. The shielding always means locking down the application's system resources so that they cannot be changed. The informational severity basically generally indicates that there might be a change to the system configuration that might create a benign security risk or an attempt to access sensitive system information. Events at this level occur during normal business system activity and generally are not evidence of an attack. We have a list of signatures that were disabled. These signatures were the ones that were disabled in host intrusion prevention, but they are not disabled in ENS. Now, the exploit prevention content file that automatically gets updated, I want to remind you that it sets the action for the signatures depending on the severity level, and you can go in and make those changes if you want to. But any of the changes you make will persist through any content updates. So a content update will not change a behavior if you select to block a medium or you select to not block the medium. It will not make that change. If you want to change the actions of your particular signatures, what you have is, first, you can filter the top part of the signatures by the severity. So if you wanted just to see all the medium severity signatures, I can deselect the high in this picture and just select medium, and then at the bottom where it has the different listed signatures, I would see only the medium severity signatures. So basically, if I wanted to block a signature, what you do now in ENS, which is different than what you did in host intrusion prevention, is you actually look at the particular signature and you select block and you select report. So what you do is you look at the signature itself, you do not look at the severity to set what is your action. So what I'll do is, if I have some medium severity signatures in here and I see that they are not selected to block or report, if I want to actually be able to enable that particular signature, I select the little box that says report. And then after a while, after I get the reported events, I can determine whether or not I feel comfortable to start blocking that particular signature. So basically, just understand, with this particular feature, you cannot enable the signature with a severity of disabled by changing the severity. So previously what we would do is we would actually go in and you would change the severity if you wanted to change what the action was. But now all you do is select block or report. So we no longer use a protection policy along with the IPS rules policy with this feature. So if you wanted to have a list of all the endpoint security exploit prevention and host intrusion prevention signatures and their current supported directives, refer to the KB article of KB 51504. You have to be a registered service portal user to be able to look at this. Do understand Microsoft Windows 64-bit base versions do not allow the kernel to be patched except through authorized Microsoft-originated hot patches. That limitation is part of the design of the operating system and is expected to be retained in any forthcoming 64-bit Windows operating systems. We will continue to work with Microsoft to identify suitable security APIs that can be utilized on any of the future Microsoft Windows 64-bit systems. We do have signatures that protect specific applications, and these are defined in the Application Protection Rules list. Now, when your attack is detected, the exploit prevention can stop that behavior that's initiated by that attack. So, Application Protection Rules lists all the default rules that we have included with the ENS. You can use this as a starting point, or you can add and duplicate and edit the different rules to meet your needs. To understand how the application protection rules and how they work, what you'll do is you define the different executables that will be monitored for exploit prevention signatures. If you do not have an executable that's included in that list, it is not monitored by these signatures. We have two classes of executables. We have the buffer overflow signatures that will provide the memory protection by monitoring the memory space that all the processes use. We also have the API signatures that will monitor all the API calls between the processes that are running in user mode and the kernel mode. Once again, remember, we will have updates to the exploit prevention content, and they will replace any McAfee-defined application protection rules that are listed in the exploit prevention settings with the latest application protection rules in that list. You can also create and duplicate your own application protection rules. The Endpoint Security Client now displays a complete list of protected applications, not just the applications that are currently running on the client system. This behavior is different from the McAfee Host IPS, because the McAfee Host IPS, when you would actually go in and unlock the console, you could actually see only the applications that were currently running and that would be protected at that time. You would not see the whole list. In this screen, we show an example of an application protection rule that is going to be protecting Adobe Acrobat. So what you do is you have the name, and then you have at least one executable that is required for this definition. In this slide, we have a list of all the executables or processes that the ENS exploit prevention protects as of October 2016. If you want to see the most current information, please refer to the KB article KB 58007. If you wanted to exclude a process, you can go into the exclusion sections and you can specify that process, the caller module, the API, or the signature to exclude. So an example is maybe I have a trusted program and it's being blocked, so I can create an exclusion to allow that trusted program to run. I can also create the application protection rules to include or exclude processes from protection. If you need to exclude processes from the exploit prevention, here's an example. Suppose I have a false positive, and it's occurring because I have behavior that might be a normal part of a user's work routine, and it is interpreted as an attack. So I can create an exclusion for that particular behavior. So the exclusion helps me reduce the false positive alerts, minimizing the needless data flow and making sure that those alerts are actually legitimate security threats. Here, for example, during the process of testing, I see a client, he recognizes this Java creation of suspicious files in the temp folder signature. Well, this signature is signaling that Java application is trying to create a file in the Windows temp folder. You'll have an event that will be triggered by this signature, and it is a cause for alarm, because why is Java going in and trying to create this executable in the Windows temp? It might be trying to download some malware. So in this instance, maybe I might reasonably suspect that a Trojan horse has been planted. But if the process normally creates files in temp, for example, saving a file using the Java application, then I can create an exclusion to allow this action. Just always remember, when an exploit prevention violation event occurs, the event that includes the associated process and a possible caller module, API, or signature will be detected. If I suspect the violation event is a false positive, I can add that exclusion by utilizing one or more of those identifiers. For your managed systems, the exploit prevention exclusions that you create in the client are not sent to the EPO server, and they might actually be overwritten when the administrator updates the policy. So if you want to make sure that you have that exclusion, be sure you create those global exclusions in your policy in EPO. When you're creating your exclusions, we want you to be sure to consider the following. Each exclusion is independent. Multiple exclusions are connected by an OR, so if one exclusion matches, the violation event does not occur. So you must specify at least one process, caller module, API, or signature. The exclusions with the caller module or API do not apply to the DEP. For process exclusions, you must specify at least one identifier, that being file name or path, MD5 hash, or signer. If you specify more than one identifier, all identifiers will apply. If you specify more than one identifier and they do not match, for example, the file name and MD5 hash do not match, then they don't apply and the exclusion is invalid. The exclusions are case insensitive. Wildcards are allowed for everything except the MD5 hash. If you include the signature ID in your exclusion, the exclusion only applies to the process in that specified signature. If no signature IDs are specified, then that exclusion applies to the process in all of your signatures. In this screen, we're showing you all the different sections that exist when you go in to create your exclusion. This is the process section. So I will go in and I will put either the process, the caller module, or the API. I can go in and put the file name or the path. I can put the MD5 hash. Do understand it is a 32-bit hexadecimal number. And I can also put the signer. Everything must match exactly. In the caller module section of creating the exclusions, you need to specify the name of the module. It would be a DLL that is loaded by the executable that owns the writable memory that makes the call. This field is required with at least one other field, the file name or the path, the MD5 hash, or the signer. In the API section, you define the name, which specifies the name of the API, what application programming interface is being called. In the signature section, you will list the signature ID that this exclusion applies to. Specify, and you can use comma-separated signature identifiers. So if I want more than one signature, I can put a comma between them. And you can add notes in your notes section. In the check your understanding, true or false, you want to log the access attempt only. Which setting best meets your needs? Is it block, report, or block in report? If you were to say answer B, report, then you are correct. If you select block, well then obviously you're going to block the application from running. Check your understanding, true or false. When I enabled the Windows Data Execution Prevention, the block action is automatically selected. Is this true or false? The answer is true. So in review, the key points we want you to remember about this module is an exploit always refers to an attack that might take advantage of your bug or vulnerability in your program or system. The key parts of the exploit prevention policy are the exploit prevention, your generic privilege escalation, the Windows Data Execution Prevention, your exclusions, your signatures, your application protection rules. The exploit prevention content files automatically set for the signatures depending on the severity level. You can make changes to the signature actions by saying I want to either not block it, And if you do that, if you get any new content updates, that change will persist. The content updates will not overwrite what your policy says. As a best practice for critical servers, set the signatures with a severity of medium to block after you do your tuning. To protect specific files, shares, registry keys, registry values, processes, and services, create custom access protection rules.